Yeah, so some of you may know me or recognize me from the this other talk. This is supposed to be my serious talk, so don't laugh, please. Also, those of you who think know me, let's forget everything you know about me, because I've been lying all this whole time. I'm not from Barcelona. First thing. I was born in 2037. That's a second surprise. And I was born actually in the United States of China, which is a country that doesn't yet exist, but it's a great country. I really miss home, actually. And there, basically in 2064, I'm majoring in computer science. I'm studying. I'm a very lucky person. I'm studying at this great technical school. It's the best tech school in all of the free world. It's the Pyongyang Institute of Technology. Really, really cool. You should send your children there when, in the future. Then, since I'm a student, I have lots of free time. Lots of free time. So I decided to take on an internship at Google. And I thought, why not? It's like, it gives you a good CV stuff, so I decided to work for them, and they picked me, which is I'm also very lucky. Thanks, Google. Actually, they sent me, so thank you. And when I started working there, basically they assigned me to this project. It's like the biggest project they're working on right now. It's called Google Settler, and it's a massive space colonization program, essentially. So it's all about, there's lots of hardware and spaceships and stuff like this, but there's a lot of software as well. A lot of software. Then it's become a real big problem for them, because this code base is 4 million lines of code almost. It's really big. It's huge. And this is becoming a problem for maintainability a lot. It's impossible to develop any new features. If we take a look at the repository on Google Code, well, formerly GitHub, you will know probably by this name. So the basic, it's mostly Go, as you would expect. Then there's a lot of JavaScript. Yeah, we're using JavaScript still. And Bash as well. So, 1% of Bash, 1% of 4 million lines of code is a lot, if you're wondering. So there's a special team just for the Bash part. It's really bad. So I'm working mostly on the JavaScript team, and it's become such a mess. It's impossible to develop any feature in less than several months, or sometimes it's years. Projects get canceled. It's lots of trillions of dollars just down the drain every time. It's really bad. It's so worrying that it's becoming kind of stuck, and it cannot work properly. So Google had, this guy from Google, Leng Bohai. He started thinking about alternatives, because it's a huge project and they had to save it somehow. So he assembled this team of people and researchers and started this project called Renaissance, which is kind of a research project where they just go all together and try and find a point in history where we had the ideas and the hardware to reinvent programming in a much better way, in a radically better way. Because that could have saved this project and probably any project in the future. So the only problem is that, the second part of the project is once they decide when this point is, then they want to send someone back in time and try and push some ideas, some crazy ideas. They don't have to be good, but just to make people think about it. The problem is that time travel is outlawed since World War III, so that's a big problem. You cannot just send people. So what they do is they send interns like me, because no one's going to ask if they can't make it back or anything. So they've done that with a number of people. Anyway, I just signed this contract. They said, just sign here. It'll be fine. Anyway, I'm having a lot of fun here. Anyway, I don't want to go back. So this is Programming the Future. And I am Txus. I'm also Joseph. So I have two names. So First question we should ask if we're going to think about reinventing programming. What is programming for? Who is programming for? It's obviously for humans. It's not for machines. And it's probably something that you already accept and embrace. But still, the tools we use are still stuck in the notion that programming is for machines. For example, we are very dependent on text-based systems. So we program firing up an editor and starting just like writing stuff, some kind of incantation, and then running a compiler, and then just like pushing to production or whatever. This is how we started. Well, it's not exactly how we started, but how we've been doing it for a while. Then there's some questions that need to be asked. Oops. Yeah, so Paul Phillips, this guy worked on the Scala compiler. He's a really smart guy. He asks, why is the canonical representation of code a string? Why is it a string? If you think about it, a string is just a type we use in our programs, just like integers or like more complicated data structures like arrays or like persistent vectors or whatever. And we use just a string to represent code. But we don't think of code as a string. So we have to translate it all the time. There's a huge taxing mental translation cost. We have to read code. We have to try and understand what our colleague meant when they wrote this method. What on earth did they mean? We don't know. We try and our best guess kind of, and then touch a little bit here, change that, and see if it works, run the tests. Then writing is another translation cost because we have an idea of a system or an idea, and then we kind of translate it to the best of our ability. As in, we know the language very well, we choose this pattern over this pattern, whatever, but we have to kind of do this translation. This is very, very costly. And we do typos all the time, come on. I mean, at least I do. We would like, ideally, some more direct form of programming. As in more direct, because like the indirection is what kind of kills us, like this barrier of text, and then we have to translate back and forth, and it's kind of not so nice. Then there's another problem that we're working with flat representations of code, which are just like text, as I've seen. It's a problem that they're flat, and they are just representations, so we should never mistake the map for the territory, as you've heard before. For example, how many people think that this is a pipe? Can you raise your hands? This is not a pipe. Surprise. This is definitely not a pipe. So if you want, what if you want to see the pipe from the other side? You can't. But you could with a real pipe, right? You cannot touch it. You cannot see how the wood is like, I don't know, made. Or you can smoke it and see what it tastes like. You can't really do any of this. You just can look at it from this angle. Because it's not a pipe. It's just a picture of a pipe. And it's in a specific angle and with a specific properties. So instead of just a picture of our code, which is what we work with right now, we'd probably like more live representation. When I say we, I just say I. I mean, I'm just pushing this opinion like and shoving it down your throat. So, I mean, just bear with me on that. Then another problem that we have with the text systems that we use is a very slow feedback loop. We type something, and then we compile, and then we wait or run some tests, and then see what happens. And that's so slow. That's incredibly slow. It's distracting. We check Facebook, Twitter, whatever. The test passed. If we're lucky, we have fast tests. This is still very slow. If we are Lisp programmers, we have REPLs. This is okay-ish, but it's still slow. It's not the best we can do. Ideally, we would like an immediate feedback loop. We change something and we see exactly the effect on all the parts of the system that we care about. Ideally. So this is just a fancy way of saying interactivity. We want something interactive. And this is partly because of the way our brains work. So the way we learn intuitively some very complex things. So an example is like our brain is capable of understanding systems that are much, much more complex than the things we're building. The things we're building are like blogs in 15 minutes or whatever, or like a marketplace or whatever. That's not complicated. We can, as humans, we can understand things like physics just intuitively. We can just like feel an object, and we don't know about mass, gravity, wind. We don't know anything. We just like do this, and then we throw an object. And we might hit whatever target we're trying to hit or not. But even if we don't hit it, then we try again, and we will probably hit it. And that involves a lot of complex physics calculations that we never do, at least not consciously. What we do is kind of learn from the outcome. We try and feel the object, we get a feel for it, then we throw, we see what happens, and then we learn from it. And our brain adapts so quickly to this that we created a mental model of what is this object and throwing it without really understanding anything about the object or the physical conditions we are in. So our brain already has this capability, and we're not using it for our code. We still make it translate text back and forth, and this is just like not the best use of our brain. Also, speed is also important. So the quick feedback loop kind of thing is also important because our brain gets easily distracted, is like prone to like overload if it has to think about many things at the same time. So it needs focus, and it needs kind of this flow to get going. You know what I'm talking about if you've probably kind of programmed in this state where everything kind of disappears, and you just go and do, and it's so productive. Maybe in half an hour you've done the work of a whole week without checking Twitter or Facebook. You know, so there's immense benefits to this. Also, speed. Some people will say, you know, typing is not the bottleneck. You're thinking, blah blah blah, and well, there's this thing called momentum, and momentum is something that our brains need to get kind of some speed. And the whole point is an increase in a quantitative measure, which is speed, just like faster, can lead to qualitative improvements. So let's take a bike, for example. You cannot just stand on a bike without movement because you will fall. But if you go at a certain speed, then you keep some balance, and then you can actually do something that you couldn't before. A plane is a much more extreme example. So the speed is even much greater, and it just couldn't fly with this speed. So in the same way, if we get this flow to a speed that's like fast enough, we can reach possibly thought patterns and ideas that we wouldn't have reached in a slower kind of way. So it's important. It's not to not take into account. Then visual metaphors are a very good way that our brain learns these things. So you kind of you have your system, and you kind of see it affected in some way. You see it change. Then your brain gets a feel for it. This is definitely not a new idea, but it's a forgotten idea, definitely, kind of. There's this talk about, if you know Brett Victor, you should watch all his talks, all of them. This talk, I'm not sure if it's available yet in this year, but possibly it's like from this year or last year or next year. You just keep clicking the link until it's available. So this talk is really, really, really nice. Then I've seen some people at this conference have mentioned programming languages as tools, as in, yeah, it's a tool, you have to use it for the right thing, blah, blah, blah. I really don't think programming languages are tools. They are much more than tools. They are the way we think. They enable thinking. So we have to be much more careful about that. It's not just a tool that you can just swap and like just throw away. It's much more powerful and much more. It can constrain our thinking very much as well. So Barbara Liskov said that programming languages are the way programmers think about writing programs. Let that sink in for a bit because that's very, very important. So now, if we were to think about programming in a different way, because it doesn't matter if it's not the best way, but I think it's important to kind of think in a different way that we do, just for the sake of novelty. So this is definitely not a controversial claim. Chris Granger said, well, programming essentially is data transformation. He's not the first or the last one to say this, but so if programming is just data transformation and everything else is just craft that we don't want, so setting up our Ruby installation or setting up our machine, having an editor that works, this is just like craft. We just want to turn a data structure into another data structure. Let's ignore side effects because they are not needed anywhere. So he also said that programming is now unobservable, indirect, and incidentally complex. That's a very ugly picture of programming, I know. But I'm pretty sure you, as programmers, you felt like this most of the days of the week, anyway. Instead of that, we could have something that's maybe visual instead of unobservable. I would have said observable, but I'm just making the leap here and saying visual, just for the sake of novelty. I mean, it's not such a novel idea if you saw the talk about flow-based programming from yesterday, about no-flow. Then instead of indirect, we would have something interactive, and instead of incidentally complex, we would have something simple. This is a very loaded word, simple, I know. But I'm just saying things here. So let's go back to the 1960s, because most of the good ideas come from the past. That's a fact. The past has also way more ideas than the present, because we tend to forget ideas. So that's why, not because we were getting dumber, but just. So one interesting idea about this time is data flow programming. And data flow programming, for those of you who didn't see the talk yesterday, it's a paradigm that's actually not so unknown as you would think. So how many people have never used data flow programming? I would say you're lying, because you've used Excel. And Excel is data flow programming. And it's so sad that it's famous just for Excel. Or I mean, there's new projects coming along, and that's great. But people basically know data flow programming from Excel. Then it's a declarative paradigm. That means you say what you want, so the what, but not the how or the when. You just say what. And that's a great thing, because it if you don't say the when things happen, that means that it's concurrent by default, right? Because time doesn't exist in this kind of paradigm. You could potentially control it, but. So let's see how it looks like if we had to actually imagine a visual kind of thing like that. So this would be, in our programming language, hypothetical. We would have this thing called unit. So we would call this a unit, and this unit would take 2 inputs and 1 output. And you can think of this as a function, kind of, but it's not exactly like a function. So this unit basically, just like that, it sits there and doesn't do anything. It just sits there. It's a suspended computation, doesn't do anything, because it doesn't have the inputs that it needs to work. So as soon as some input comes in through this wire, it still doesn't do anything, because it needs both. So what happens when actually we get both inputs? The unit kind of activates and forwards the result to the next connection. So this is pretty easy to grasp. We could probably see ourselves programming this way, maybe. I don't know. But let's kind of give it a little bit more thought. And what if we take all these learnings from functional programming, even if you don't believe in functional programming, and try and apply it to this data flow kind of paradigm? So let's say, for the sake of beauty and elegance, that units are the only primitive, so there's no code, as in text code. It's just units. Everything is units, down to the most primitive ones. We would also say that they are generally pure, except some of them that perform side effects, this kind of nasty, ugly thing that are side effects that we don't want to deal with. And then they would maybe have statically typed wires, so that would basically enable us to compose them very easily using a lot of learnings from functional programming. How do you compose these things? First question. Well, if you have 2 units and they are typed this way, they have this arity, so 2 inputs, 1 output, 1 input, 1 output. It seems pretty obvious that if the first unit has the same number of outputs than the inputs there and the same types, you could just connect them with a wire, or just like fold them this way and make this one unit that just adds 2 numbers and then doubles. So this looks pretty good for composing stuff. Then what if we want to reuse those things? Because we don't want to reinvent, add every time. So we want to create libraries that people can use. So with that, we could actually use this idea from functional programming, functors, and have functor units that basically take a unit that exists and operates on int, and now it suddenly operates on some maybe int or in some other type that our program uses. So this way we could publish libraries and let people play with them with their own types. Now, this is all nice, but why are we not there yet? So why is there basically no, with exceptions, no programming language that works like this? They are similar, but they are kind of not in like huge adoption. And definitely they wouldn't make it to the top 10 programming languages, which is not a good place to be, by the way, if you look at what those languages are. Well, one of the problems is that the present is the least important time we live in, and we don't know it. We're obsessed with the present. And we're obsessed with what we have right now, and say, basically, we don't think about the past enough, so we obsess with what we have right now, but not what the ideas in the past were, which most of them were lost, and some of them should be probably taken into account when we think. Then the future is definitely much more interesting than the present, because we're looking forward to it all the time. So why are we so obsessed with the present? We should basically disregard everything we have right now and try and rethink using the past. Also, a quote that is actually mine, I agree with it because it's mine. So the present is always a suboptimal outcome of the past. Always. I mean always, because it's like by definition. From all the presents that we could have, it's not the best. So we should totally take that into account when we think about the present that we have, the tools that we use, and the programming language that we're using. There's another problem that's inherent to kind of human nature. There's a kind of this struggle between technical novelty and wide adoption. There are many, many examples of this, but let's, I don't want to make any enemies here, but I would say, for example, if you take, on the upper side, we could take Clojure, and on the downside, we could take JavaScript, or ClojureScript and JavaScript, for example. One is definitely a superior programming language respect to the other. I'm not saying it's the best thing, but the other one is just everywhere. Virtually everything runs JavaScript. So this is kind of a very hard struggle. Another one that kind of everyone will relate to is, it's a little bit more controversial, but in the wide adoption kind of things, we could say the Unix is there. If you haven't read this book called The Unix Hater's Handbook, you should totally read it. It's a lot of fun. It's about these people who had experiences adopting Unix, and they had a lot of problems because it was the early days. And the book is from the late 80s, I think. And they were like, oh, I lost 4 days of work because of this bug in this thing, or because, I don't know, in general, Unix utilities, when they can destroy something and replace it with something, they first destroy whatever, and then check if they can perform their work. And if they can't, well, they already destroyed the thing. So that's kind of how it used to work. And it still works like that if you check some tools. So that's probably not the best operating system we could have. It's definitely the most widely adopted. So that's a problem, because in that time, probably there was maybe better ideas, and they just got lost. And now it's so hard to replace what we have. It's so hard. It's just everywhere. So I went to Google I/O in 2061, and I got this quote from the Google CEO. Basically, they admitted that they said Go was so cool. The tooling was so amazing, and people just went on with it, and it was fast, and it worked, and you shipped binaries, and it was great. And then people got lazy. They just got stuck in this local maxima. And they kept like shipping just Go things everywhere. And then they just never thought, could we have anything better? So they, even when they started the Google Settler thing, they started in Go, of course. And now they're where they are. So they're not, I mean, I'm not saying it's the Google CEO. So, you know, it's like basically admitting defeat. And hopefully maybe there's a way to fix it. There's another quote, kind of to close. Leng Bohai, the kind of Renaissance lead, said, "I curse the day when software turned its back on computer science, because from that day we focused on just finding better answers instead of asking better questions." And I couldn't agree more. Actually, asking questions is much more important than finding answers. So instead of solving problems that we have, we should probably ask better questions, because then we could maybe avoid getting stuck in local maxima, which is the worst thing we could do. So, yeah, with all these ideas, kind of a crazy overview of data, visual data flow programming and all this stuff, I'm not saying that it's maybe the best programming language that we could use, but I think it's interesting for you as an exercise to think about other crazy novel ideas of programming languages that you would like to see in the future. And they don't need to look like C and be like Go. They could be something else, something better. So basically, it's up to you. Thank you for making history. And I'll take questions if there's time.
So you were talking about the problem with adoption of new technologies, and you mentioned the JavaScript as an example. So the thing is that JavaScript is already there and it's everywhere, as you said, but if you think about alternatives and things that might replace it, there is CoffeeScript, there is PureScript, there is TypeScript, ClojureScript. So I think the problem is that they are all competing for the same thing, and that could be the problem in just being stuck with JavaScript all the time. So what do you think about that?
Well, in my opinion, the problem is not between JavaScript and CoffeeScript, but more about having a broker, like a broken browser ecosystem. So in my ideal world that I can imagine, probably there's much better ones than this one, but we would have a browser that is basically just like a virtual machine specification, and then you just run whatever programming language you want that compiles to that. Instead of having JavaScript and compiling to it, that's just not, JavaScript wasn't designed to be an assembly language. And we're doing that because we have no choice, honestly. That's why. But ideally, we would have had a much better platform from the beginning, but obviously, in hindsight, it's very easy to say.
Hi. So you said you come from 2067. So I have a question. Did Sagrada Familia get finished by that time?
It didn't.
I thought so, thanks.
It's a little bit like this project. It's just never stuck. Just stuck.
Hi. So I think one of the problems for adoption of new technologies is momentum of the current thing. So if you educate people in one paradigm with certain technologies, obviously they're going to keep using things that either are that technology or look like and feel like that technology that they've used before. Do you have any ideas on how we can disrupt that in any way and sort of stop the momentum and move it in another direction?
I really have no, I mean, my best guess is just like kind of talking about it. Just having, looking for novel things and presenting them to your peers and kind of getting people excited about it. It's the only way. Because, you know, I mean, Also, if you actually have an impact in the industry, so you can try, if you're in a position where you could try a technology in your industry and kind of change a little bit, it would be an example for other companies to do the same. That obviously, like, industry is very important to have on your site for these kind of things, because industry is what actually adopts all these technologies. So we need to kind of have them, and not only in our kind of ivory tower or, like, you know, our classrooms.